This is the first video in our series on monopoly. So we're discussing chapter 14 and monopolist, a very different form of market structure than perfect competition. So as we discussed in class, in our definition of monopoly, there is one firm with a unique product who's erected very high barriers to entry. And we're going through their sources of market power at the moment and different examples that match those reasons for monopoly power. What this video will focus on is why in monopoly, price or demand is always greater than marginal revenue. And that's because the monopolist is subject to the law of demand, so when they raise their price, they also lose a few customers. So each unit is not bringing in the same amount, it's bringing in less than the price. Right? So just to set that up and how it's different from perfect competition, let's consider two different firms. Let's think about a wheat farmer. Our most compelling example of perfect competition, right? This firm is in a perfectly competitive market. And then let's think about Apple with their iPhone in 2008. First firm into the smartphone market makes them a monopolist. So the wheat farmer is just such a small drop in the bucket that we call them a price taker. There's some large global market over here with supply and demand setting the equilibrium price that then becomes the individual farmer's price and their perfectly elastic demand curve. One thing we mentioned but didn't spend much time on is that this is also their marginal revenue. Every single bushel of wheat that they sell brings in the same amount. I don't know, maybe it's $1. Each bushel of wheat earns $1 regardless of how many quantity they supply. They're just a drop in the bucket. Increasing their supply will have no impact on market price and no change in quantity demanded. It's not like they release a bunch of bushels of wheat and so the price drops for everyone, which causes the quantity demanded to rise. No. When they release extra wheat, nothing changes, right? Price is equal to marginal revenue because each bushel brings in the same amount. That's very different from Apple. They are not a price taker. They have complete control over price. No one is going to come in and if they charge $1 more, offer exactly the same product for $1 less. There is no substitute for their product because they're the only firm in the market. So they can charge whatever they want. That doesn't mean people will buy it. They are still subject to the law of demand, which says if price rises, quantity demanded will fall. So if Apple goes out there and produces a ton of extra iPhones, they're going to drive down the market price for iPhones, right? Flooding the market is going to be, they're a big enough share of the market to drive down the price for everyone. When they increase the quantity they supply, if they want to sell more of them, the price will have to drop. There will be a drop in price that corresponds to the increase in the quantity supplied. So changing their output will change the quantity demanded. And that is a little bit easier to see when we bring in some good old column algebra. So let's think through the algebra of Apple's marginal revenue. Say there's a bunch of different prices that they can charge for the iPhone, and they're trying to figure out which one they should charge. They do some market testing and they see that they poll some consumers and they predict that if they charge $800, no one will buy it. Right? This is when the smartphone is still new on the market. Nobody's really sure what they are yet. If they charge $700, maybe they think 5 people in our class will buy it. At $600, 10 people will buy it. 500 people, 15 people will buy it. And at 400, 20 people will buy it. And at 300, 25 people will buy it. This is just the law of demand, right? This is actually the quantity demanded at a bunch of different prices. As the price falls, more and more people are willing to take a gamble on this new product. All of this translates to Apple's total revenue. Remember, total revenue is just price times quantity. How much do you charge multiplied by how many people do you sell to? Well, if they charge $800, no one buys it. They don't make any money. 700 times 5 is $3,500. 600 times 10 is $6,000. 500 times 15 is $7,500. 400 times 20 is $8,000. And 300 times 25 is $7,500. So if all Apple is thinking about is how to make the most amount of money, maximize their total revenue, they should obviously charge $400. That's where their total revenue is highest, right? At any price higher than that, the customers they lose is the customers they gain are not enough to make up for the dip in price. We know that it's a more sophisticated decision than that. Apple will not only think about total revenue, but total cost when they think about their profit. So we don't know yet anything about how much these different amounts of iPhones cost to make. We might expect diminishing marginal productivity and some increasing costs at some point, but we're not thinking about that quite yet. What we're trying to think about right now is how does their marginal revenue change at these different quantities on the demand curve. Remember, marginal revenue is the change in total revenue divided by the change in output. How much does each additional unit of iPhone sold bring in? So we can't calculate it at 0, but between 0 and 5, the total revenue goes up by $3,500, while the quantity goes up by 5. So $3,500 divided by 5 is $700. Between 5 and 10, total revenue goes up by $2,500, total output goes up by $500. Between 10 and 15 units, total revenue goes up by $1,500, total output goes up by $300. Between 15 and 20 units, total revenue goes up by $500, total output goes up by $5, so $100. And between 20 and 25 units, total revenue drops by $500, total output goes up by $5, negative $100. So this is what the marginal revenue looks like for the monopolists. Notice that at every quantity except between 0 and 5, it's less than the price. So between 0 and 5, the price is $700, marginal revenue is $700. Between 5 and 10, price is $600, marginal revenue is $500. Price is $500, marginal revenue is $300, and so on, until it dips below and actually goes negative. The way we would draw that in quantity of iPhone and then dollars per unit space is a downward sloping demand curve and then a marginal revenue curve that is always twice as steep. When demand is linear, marginal revenue will have the same y-intercept but be twice as steep as the demand curve. And there is a little bit of because calculus to that, but for our class, all you need to think of is a demand curve coming in and the marginal revenue coming behind it, twice as steep. At every different quantity, the price is greater than the marginal revenue, right? The demand curve is telling us what they can charge for every quantity. That will be the price. And the marginal revenue is telling us how much extra money did each unit sold bring in. I hope that math helps make this a little bit more clear. We'll talk about it together in class on Wednesday, and hopefully I can answer any of your questions. But when you're drawing the monopolist graph, remember, marginal revenue always less than price, twice as steep. We're still going to think marginally and use it to make all kinds of decisions, but it looks very different than it did in perfect competition. Okay.